All right. Welcome, welcome, welcome. Programming, JavaScript, types, all that good stuff. Yay. All right. Mm-hmm. Yep. No. We'll talk about that afterward. But I think yes. Dum, dum, dum. Right. Oh, good cakes out there. Oh no, waffles. No more for me, thank you. Dup, 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 dup. Nothing, nothing, nothing. I just need to check, like where are the insulin syringes? All right, let us get this show on the road. TypeScript and Node Package Manager, NPM. How on earth does this fit in with SuperOffice? SuperOffice is all C# and SOAP, stuff like that. What on earth could this all be? That is me. It's a little crazy at this point. Node. What on earth is Node? What is TypeScript? What's a JavaScript library? What? And all these questions and more will hopefully be answered. Node. Node is JavaScript on the server. It's like not in the browser. So JavaScript has had it's changed a lot. And there are good parts to it. I mean, there's even a book, JavaScript, The Good Parts. I mean, it's very short, but but it's gotten quite fancy. You can do a lot of useful things now outside of the browser. So, like you saw, the Zapier integration is all based on this. That you write your connecting glue logic in JavaScript and ship it off to their server, and they have infrastructure to run it and host it up in their cloud. And there are many, many packages for Node. So Node is essentially the JavaScript engine from Chrome, repackaged and repurposed to run as a command line parser or execution environment. And you can, this is from their homepage, this is how you would make a simple web server. So you set up a little thing, a little function that says, like, when somebody calls me, I will set a header and I will respond with a little message saying, hello world, and then I will start this server on a particular port, and it will run, and it will sit there and answer if anyone asks for, calls me, I will send back my little response. Now, and that's a trivial example sort of a web server. You can add lots more, with different URLs and different content types and routing and content negotiation and so on. But it's like you don't have to write a server doesn't have to be a big scary thing in C++. You can do it quite simply. So NPM is kind of the other big portion of this, the Node Package Manager. And the two have kind of evolved alongside each other. You know, having a little JavaScript runtime that you can sort of shop around. And Windows had that, 20 years ago. We had JavaScript on the command line, you know, JScript exe. But the thing that's kind of made Node really take off is this idea of packages and being able to pull in modules and all their dependencies with just one extra command, and sort of adding all that into your package, into your application easily, and then being able to reference them and update them quite easily. So you do something like sort of npm and then a command like install, the name of a package, and it will download the package and all of its related parts, all its dependencies, and stick them into Node modules for you. And then in your code, you basically refer to the package by name, and you get access to its functionality very easily. And also its source code and tests and things are all sort of sitting inside this Node modules folder. So it's very handy. See, if Microsoft had done this 20 years ago, the world could be a very different place. And then finally, TypeScript. What on earth is TypeScript? Anyone know? JavaScript with types. So they having made C# better and .NET better, the Dane who started out with little Turbo Pascal kind of wondered, what should I do next? You know, so like, oh, let's fix JavaScript. So basically, the idea is that any JavaScript program is valid TypeScript. So you can take any JavaScript program and basically change it, you know, from .js to .ts, and it'll still work. And TypeScript is basically adding information about types and making those assumptions about types more explicit, and then telling you like, no, oops, you're trying to do something you probably didn't mean, like you're trying to add a number and a string, and you should, you know, be more. You need to explicitly say what you're trying to do here, otherwise JavaScript will do something you didn't expect, like put a number on the end of the string rather than adding two numbers. So the TypeScript part here is basically that colon string. That's the thing that makes it TypeScript. And these declarations, you can gather them up into interfaces and so on. But all of the things which are in JavaScript are also in here. But it just gives you a way to be more explicit about them. So TypeScript has a whole a fun syntax for sort of saying things like, oh, this is a string, or it could be a number. You know, so it's like it's definitely not C#. It's way more loose because it's based on JavaScript. So the way you install it is you use Node package manager. You say npm install and then -g to say globally. You install it so I can access it from everywhere. And that gives you a little compiler called TSC. And then if you have a little function like this, you compile it, and that turns into the dramatically different JavaScript there. It's like, woo, woo, magic. So, you know, it's functionally exactly the same. The only difference is like the type information has now disappeared because JavaScript doesn't care about types explicitly. It cares about them, but, you know, it'll only care about them at runtime. So TypeScript gives us a bit more sort of information at compile time. And it stashes kind of the type information off into a separate file. So there's a hello.d.ts, which includes the type information. And things like Visual Studio Code and other tools can use these declaration files to provide IntelliSense and better tooltips and things while you're programming. And that's kind of, I think that's half of the purpose for TypeScript, is like just to give you a better experience while you're programming. And then finally, there's a map file that says, okay, this line in the JS file corresponds to this line in the original TypeScript file so that when you're debugging, it'll stay in sync. Question? Yes, if you can add things, add code documentation to TypeScript, which also gets stuck into the declaration, the DTS file in the middle there. So code docs in TypeScript are very similar to what you have in C#, but they're not with XML. It's a lot more lightweight. But yes, those are also good. So we have we have made a small node package of our very own. So you would install SuperOffice WebAPI TS client, and then write some code. Easy peasy. And then compile it. So basically take my TypeScript and turn it into a JavaScript file. And then we would run it. And hopefully we would get back some information out of SuperOffice. So not too dissimilar from, sort of everyday development, except there's no Visual Studio ID. It's in Visual Studio Code or Notepad and the command line. But the process is the same. You write some stuff, run the compiler, and then see if it works. And so this is what I pretend typed. This is our TypeScript. So go get me an agents thing from the package I installed. So import from Super. Annoyingly, Node prohibits capital letters in its package name, so we cannot have the canonical capital S, capital O in SuperOffice. Must be lowercase. But the agents API, we can make a new one of those and can point it at a SuperOffice installation, the URL, and we can tell it like, oh, please log in with username and password, or with ticket. There's a whole bunch of different ways of authenticating. So once we've set up kind of our connection to SuperOffice, we can then say, okay, make me a contact agent that I can use to call methods on. And then get me contact number 2, please. And then once you have gotten that, then write the name out, on the console. Very complex. But half of the fun here, of course, is the whole point of TypeScript is the IntelliSense and stuff as you're working. So let's see if we can. Let's see here. If I go new. Let's see. Come over. Ha ha ha. There we go. Let us see if I can. Let's see. Save. And then. Oh, sorry. Test 1. TS. TypeScript. Yes. Okay, I have no idea what that was. So let's see. Before I should probably do the thing I mentioned in my slide, which is install the package. Otherwise, this will be a very short demo. If we go, so CDS, no, CD down, downloads, types. There we go. Install SuperOffice Web API TS client. Like, is that a good name? It's like, I have no idea if that's actually a good name or not. Yes, it's a bit long, but it's accurate, which I think is a good thing. We could have called it something else, Fogger with no vowels in it or something, but like the cool kids do. I don't know. It's like I can imagine other clients coming along at some point. maybe. Super ID client, for example, would be a blah, blah, blah. These complaints, these warnings are all about the little test project I have here. But one of the things that's happened now is we have a Node modules folder, and it's got SuperOffice in it, and it also has a bunch of supporting features, like other R dependencies also installed there. So now, I should be able to say, do the import. Agent API from that from lovely. Oh, and see, now it's gotten like, oh, that was wrong. It should be like that. Oh, and semicolon. What the? There. So, and then API equal new agents API. Here we get nice IntelliSense and sort of tab completion, and then parameters and many different ways of instantiating this thing. So if I now go http research.superoffice.net/test/ and API dot authenticate with password with ticket. Item 0 has no password. Lovely test database. We do not encourage this. We don't intend this for production use. So now let us make, and then we can go get a, one of these. There we go. And here, again, documentation is always nice. So this is documentation that we pulled out of our tools and sort of include when we're building the modules here. So now I can say, okay, agent dot get, and then I can say get contact. Boop. I need a number. Boop. And then because this is an asynchronous operation, it returns a promise. In other words, it doesn't actually return an answer. It returns like a thing which will eventually be executed later on when it's done. And so the traditional way of doing this has been to use then. So you stick on sort of additional functions, anonymous functions, to kind of handle this stuff. And so the nice thing with TypeScript is it will do typing for these things. So it knows that, okay, get contact returns a contact, so it's kind of stuck that in for us. So we can say, okay, contact is our return parameter, and then we can say, blip, console.log name equal. Now I'm old school, so I do concatenation rather than the new fancy backtick. Contact dot. Did I mess something up here? Blah, 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 blah. Oh yeah, contact. Suddenly I get verbose. Contact dot, and then all the properties that are declared in the service object. So it's like, ooh, here's full name, our name, organization number, name's the one we want. There we go. Bleep. So save that. And then from our command line here, so we would say it's TSC, and then what did I call this thing? Test1. TS. Cross our fingers. Oof. Now I have a test1.js, and I can run that. And it prints out state0 database, which is our test. Yay! So, anyway, so back to the slides. So, the code is not the important thing here. It's more the experience of using this in the editor. Like the editor will give you a bunch of support in TypeScript mode. Right. So there are, okay, so other things, of course, JavaScript has gotten async and await. Yeah. So TypeScript has async and await also. So one of the things we can do is we can say, instead of doing the dot then, done, then, we can say, oh no, await the result, and then we can write more kind of serial code, more linear. And one of the annoyances, of course, is that you can't do this in the main body. You have to stick it inside an async function and then call that, because for some reason it's impossible for the main function to be asynchronous. So we could do this, and we get an error. It says no. Async function require in ES5, ES3 requires promise construct, blah blah blah, must include. So it turns out we are still living in 1998. The ES5 and ES3, ECMAScript 5 and ECMAScript 3 is kind of JavaScript as it existed back when back before I started in SuperOffice, so a very long time ago. It turns out that's the default. Like they chose the default version to be the oldest one, to be most inclusive. So it's like, okay. So you could, in theory, make, if you include all the libraries and so on to the polyfills, the ways of declaring, you might be able to make TypeScript work with IE6, or kind of the IE6 generation of JavaScript. But it turns out you can configure it to kind of go like, no, we want to work with slightly more modern JavaScript. So there are two things. One is the target, which basically is what kind of JavaScript are you going to output. ECMAScript 2015 or 2016 is a fairly nice modern variant of JavaScript, and kind of what Node supports natively. And in fact, what most of the browsers support nowadays is these things. IE11 is the only one which is kind of not quite there yet. And no one should be using that anyway. And then the other thing is modules. How does it find kind of the modules that you're referring to? And there's a whole bunch of different systems for this. And it turns out we need to expressively say, please use the common JS version, and things suddenly start working. So there's a couple of ways we can do this. One is we can make a config file, which basically tells the TypeScript compiler that use this for all of the TS files. Or you can explicitly compile one file at a time, which is fine for us. And then in that case, you should just put it on the command line. So if we do this, we say, no, please use a modern JavaScript. When you're compiling, then suddenly it works, and we can do the same thing again. We can run Node, and voila, we get output. So that's all good. Yay! So can we do this with JavaScript? Do we have to use TypeScript? What if I don't want TypeScript? It's yes, you can. What we do is when we're building our little library, this library comes straight out of the source code of the production version of SuperOffice. This is part of the skill libraries that that we use in our new user interface. And what we do is we basically take that little part of the skill libraries and clean them up a bit and compile them from TypeScript to JavaScript, and then ship the whole stack up to Node. So there's TypeScript files, but there's also JavaScript files for all this. So if you, as JavaScript, you say, okay, require, which is the JavaScript-y way of doing an import, or one of the many ways you can import a module in JavaScript. There are at least 6, I think, and I'm not going to cover all of them. But basically, we say require name of the module. That gives us kind of an alias, a namespace for that. And so, unlike TypeScript, we kind of have to use the namespace prefix here. So we say new agents API, and then the rest is kind of very similar. And because of the typing information is included for the TypeScript files, Visual Studio Code will still pick them up and kind of try and it will infer as much as it can from the TypeScript and kind of from the typings, the type information that the TypeScript sort of leaves lying around, and kind of go like, oh, you have a contact agent, then you will have these things on it. So as to the greatest extent possible, it will kind of try and assist you while you're typing, even though it's not actually TypeScript. It will kind of go like, well, I see this thing has TypeScript definitions, so I will pick them up and then show them to you in IntelliSense. Sometimes it will guess wrong, and you'll get kind of odd suggestions. But for the most part, it's very helpful, even when you're working in JavaScript. So it does the same thing. We can stick all that in a JavaScript file and run it, and it will also work. You know, it will do the get a contact and then blah blah blah. JavaScript has promises, the asynchronous stuff also supported. So Node does that. So that works. Yay! So the JavaScript also has async await, or at least modern JavaScript does. So we can do the same thing with async and await. And again, we have to do a separate function. So we have to declare our async function and then await the get contact. And then JavaScript will kind of do its thing where it says like, oh, okay, I will take the rest of this and put it on the stack for executing later, and then continue when it's gotten a response. And again, it's like, well, you have to put it in a separate function and then call that function from the top level. But that also works miraculously. Super happy. But what about browsers and HTML? Like, what if I want to use this library on the web page? I mean, it's like, well, yes, of course, obviously, because that's where we use it. We use it in our new web page framework, skill, SuperOffice component something something language. I forget what it stands for. There we go, interface language. So it's intended to be used on web pages. That's kind of the its primary purpose is to help us when we're trying to call back to NetServer to do function calls and the method calls there, to do that in a sort of consistent and safe way. So, how would you do that? And there are a couple of ways of doing that. There's Browserify, which is kind of the easy one, which I've picked up here. And there's something called Webpack, which is a lot more complicated, and which we use, and which breaks every 5 compiles. So that's why we're not using it here. But basically, Browserify does solves the problem like, how do you deal with all of these bits of code which say require? Like we're basically when you're running on the server, it can kind of go off in the file system and look in the node packages, in the node modules folder. Sort of I'll find the appropriate package and go look up its declarations and things like that. But the browser can't. It doesn't have access to the file system the way the node does. So what does what does it do? So Browserify does the work for you on the server. It kind of picks up all of the different modules that you've referenced or included sort of directly or indirectly, and puts them all together in one giant JavaScript file. So you basically tell it, like, install the Browserify tool, and then take my little JavaScript function or file and all of its things, and I'll put them into a bundle. So we have bundle.js, which contains all of the different modules that we've referenced and used, plus your little program at the top, which actually does something. And then you can reference that from a web page, and you can, and if you, in our case, we ran automatically, like the script just writes to the console. But I'll show you an example afterward where we can actually do some something a little more interactive. But it runs on the server, and it runs on the client also. Or at least, maybe not. It turns out, when you're running on the server, you can do pretty much whatever you want. It's like, well, I'm the program. I can do whatever I want. Nothing bad is going to happen here. I have control of my whole environment. I can read files. I can call whoever I want. Inside the browser, it's like, no, the browser's boss. So you want to try and call someone, the browser is going to call ahead of you and say, like, can we come play? It's going to do an options call to check if you're allowed to come over and talk to the server. And if you have not configured CORS, what is it called? Cross-origin request something. The browser will basically go, can we come? And if the server doesn't give you a valid response, it basically doesn't have your name on the list of who is allowed to come over, it will say no. And then the browser will go, I'm sorry, we can't call this. That's a security, it won't talk to us. So in that case, it's like, well, you have to reconfigure your server to allow the web page that you're trying to write to come over, or do without. So if your server basically doesn't have the different sort of origins, the different URLs that are allowed to talk to it configured, you need to set that up. And so the way we do that is in the web config file. There's a WebAPI section. One of the things we have to enable is CORS, so CORS enabled, true. And then there's a CORS origin thing which says, basically, these are the URLs that are allowed. And you can list more than one, or you can list a star, which basically means let everything through, which is very handy for development. But in other cases, it's like, no, you list up this bunch of, and by default, it's CORS is on, but it's only the only allowed people are, I think, the web tools and Mailink. So if you just try to talk to your installation, it will probably say, no, not allowed. All right. Ooh, demo. So let us take a look. Boom. So I have done something. Yep. Not this one. Here. I have a simple web page. So I have bundle. Where did bundle go? I am now nervous because did I not move? Oh. One moment. Yeah, you should be in here too. Much better. There we go. So this is the result of the bundling operation thing. I talked about it earlier. It has a function in here. It has two actually. It has a little set up the connection and log in with a username and password. And then there's a function, and we attach it to the window object. Because the bundle kind of isolates everything inside it. So in order to expose some of the functions, it's like you can export them and do some importing, or you can just stick them on the window object. And because I was fixing this up at about 12:30 last night, or this morning, I went with the easiest option. So it says window, and then a function. And we can even do this for asynchronous functions, it turns out. So we can say async function, do that, and then await the contact. And here we're getting the ID from outside. And if we look over in our HTML file, I have a button that I should put a value on so that we can see it. Value equal click me. There you go. And what that does is it calls this local function here. This function gets the ID, gets the value out, and then calls our little function that was stuck on the window. And awaits the answer. And then this is what gets back is the nice contact object. And then we take that and sticks it into a h1 name down here. So now, if we Oop. There. This one. No, here. And if I go drag, perfect. So here is our lovely. So if I say click me here, you will go get contact number 2. And if we can now bump that number up and click me again. And it goes off and gets a different contact. And then we could even, let's see, you'll put a breakpoint in here. Okay, do it that way. Click me. Woohoo! Now we got a C with our with all the properties from our API call. So it's like, yay! So it's like, oh, lovely. So that's nice. So our API, our library works on the client and on the server. Where the heck was I? There. So yes. So and it's used in the skill project, you know. So it's like even Stadler and Waldorf are entertained. So it works with TypeScript and with JavaScript. It works then and then and then and asynchronously. Async await, and it works on the server and in the browser. So it's like, good job package. So, okay, what is actually in the box? All of our agents. This is like half of them. We have a lot of agents after a while. So all of the things which are in the services API, they are in the TypeScript client. To make this a little easier to navigate and so on, we have one main entry point. So we have this thing called Agents API that you can configure and set up your options. And then from there, you can go get the different agents that you want to sort of use. So the Agents API object doesn't have any sort of major functions of its own. It's mainly there to kind of let you configure and set up the connections that will be used later on. But it's a way to sort of get you started and you sort of point you in the right direction. And then from there, the IntelliSense should be able to lead you to whatever thing you're looking for. So for example, contact agent, we have all the methods on contact agent. So you can say get contact, and get a contact object, get contact entity, you get the big version. All the methods, is number valid, and then there's a request object, and the request object has an ID and a number property. But these things are all declared in the TypeScript, so you get nice IntelliSense of how should your request object look. All of these return promises. So there is no method that you can say like call it and then wait for the answer. It's like no, you will get a promise and you have to then it to actually get something done. There are no HTTP errors. This is not the REST API. These are the agents. So there's no 404 not found. If you say get contact ID 1234, you don't get a 404. You get null. Some people like that. Some people are going to go like, no, that's not the right way. There's no get methods or put or patch. But of course, all of these kind of hide the HTTP underlings from you, so you don't really have to think about that. But these are not kind of REST APIs. These are method calls. They're like SOAP, but with JSON. Comments, questions? No? So yeah, promises, yes. So you can await them or you can then them. Well, everything is strongishly typed. So for example, we haven't declared any classes as such. We declare lots of interfaces that say this is the shape of the data, but we're not declaring anything as strongly as a class. We don't have to say this, you must be exactly an instance of this thing, of this particular class. It's like, no, you should have roughly these attributes and it will be good. So you can say something like, this is an address, and the address has, at least, well, it has a latitude, maybe, it maybe has a localized address. So in this case, it's like, well, we have a street address, and street has a city on it. So it's like, okay, fine. This is perfectly valid. It's got like some properties filled out, and the rest are null, basically unknown. So you could ship this off, and something will happen. But it's there to get kind of, when you come to the curly brace here, the IntelliSense will kind of help you fill in the structure. So that's a good thing, I think. Questions? No? Seemed like a good idea. So REST API, do we need the REST API also? Like, should we invest some time in kind of making the REST API that we have kind of sitting alongside the agents, should that also be available as TypeScript proxies? Should we have something like this, where you could sort of, it's more focused, it doesn't cover everything, but it's more like the other APIs you might play with. Like you would, if you ask for a company that doesn't exist, you will get a 404 error, things like that. Is that a good thing? Questions? Come on, or feedback? No? Nobody cares? Nope.
This is a good day. It's useful. Where are we wasting our time?
It's like nobody cares about TypeScript, really. It's like no? Yeah.
How do you see TypeScript if we're going to look at the last session about series and what's coming?
I can't. I have no idea what you're talking about. Yeah, no, that's a good question. What should we do with CRM script going forward? Like, should should we make a CRM script to TypeScript compiler and say like that's what we're going to use now? It's like that. Maybe that's a good idea. Maybe that's a terrible idea. Jens and I are going to have a fight later on. We'll see. Yeah, the next year. Mud wrestling.
But seriously, guys, think about it. CRM script is our private language. It's never going to become as elegant, powerful, and well supported as something that Untitled is throwing his weight about.
I think TypeScript is more standard.
So the question is, do we want to transition? Do we want to keep our own private language? Or do we want to switch to a mainstream powerful language? You're the ones who use it. We actually don't use CRM script all that much. You do. And so it's a question that you should be thinking about, because it's a genuine question from us. There are people in R&D who think it's a good idea. There are people in R&D who think it's not such a good idea.
Guess who?
And I don't see that we, at this point, know enough to be able to resolve the question.
Yeah. Should we write? I'll make a form, a questionnaire that you can fill out and go like, I love.
Just yes, no.
Yeah.
That's the most
Think about it. Think about what it might mean to you. Think about what the upgrade path should look like. Because I'm not going to commit to say, if we go to TypeScript, we are going to 100% perfectly translate all existing CRM script to equally valid TypeScript that has the same outcome. And that would be great. But, that's one of those promises that's like, he doesn't know what he's talking about.
Yeah.
Probably. So, what would the upgrade path be? How long should they coexist? Or do you just hate the whole idea? Think about it. Come back to your answers and viewpoints.
Yeah.
Yeah, CRM script has been here for a while.
It's been here for a long time, and it has a bunch of functions which are very CRM or customer service specific. And so, what would they look like in a TypeScript world or a JavaScript world? Yes.
I say if you asked for like 3 years ago or something like that, then I would probably have said yes, you should go with something like TypeScript because it would be much easier for people to learn.
Mm-hmm.
But I would also say that after you have implemented this great new editor, it has been much easier to get into CRMscript and start to work with it. So I would say from my personal perspective that right now it's not that important for me because it's pretty easy to get started with CRMscript right now. Comparing to just how it was for like 2 or 3 years ago.
Oh, yeah. Well, then, one of the things that's sort of weighing heavily on us is this zipper project, Project R, that Jutta mentioned way back yesterday, all of 30 hours ago. How basically most of the business logic and so on needs to move from the customer service over onto the net server stack. And so we're faced with this problem of like, what should we do with CRM script? Like, do we re-implement the parser and the execution environment? Or do we pick up an existing functional, interpreter, like a JavaScript interpreter? These already exist for .NET and have, a whole bunch of additional features and optimizations and so on, so they run a lot faster. And, so there are benefits there. But on the other hand, it's like, well, then we need to figure out what we're going to do if we convert. So it's like, oh, maybe we should re-implement the existing one. And then it's like, oh, then we have to re-implement all the other editor and all that stuff. Yeah, Jens.
So if you're moving more and more business logic to browser, should you then implement support for running CRM script in the browser?
Ooh. Well, I saw I saw somebody, or a tweet went by the other day about someone was running Windows 95 in the browser. So you can, the emulation technology got to that stage. There's like, for a couple of years now, there's been like you can boot Ubuntu, Linux in the browser. Like it runs a full virtual machine implementation and the whole code stack, so it's like the browser can do a lot. It could, in theory, do just that, run CRM script. Although running an interpreted language on top of a bytecode interpreted language it's like performance-wise, I don't know how, well, maybe it's gotten pretty good, so maybe it would be doable. All right, authentication. We have a bunch of methods for authenticating, for saying, this is how I would like to prove myself to the net server backend. First method is not to do anything. Like, don't say anything. Just trust that there's a cookie or an integrated login that will kind of that will be handled for you. I do not recommend this approach, but it could work. If you are SuperOffice, it kind of works because you are running inside the browser session with an XRS cookie that sort of says you have logged in already and we trust you. But everyone else can't rely on that. So in that case, there are 3 different ways of authenticating. You can say, here's my username, password. You can pass in a ticket or a token, essentially. And these all basically just set the HTTP headers under the covers to the appropriate sort of values. There is the 5th option is to go talk to the underlying sort of HTTP mechanism we use, which is called Axios. So you can configure that to say, oh, here's my username, password, or here's the magic headers I need to add to my request. And you pass that in when you're configuring the agents API or the agents, and it will sort of trickle on down through until the actual request gets fired off. Now, one of the questions here is, okay, let's talk about that first. When these all kind of assume that you've gotten your ticket from somewhere else. Like none of this doesn't handle any of the interaction with SuperID in online, for example. It's all very kind of just tell me what you know and I will pass it on. It doesn't do any of the OAuth authentication magic. That's kind of left to someone else. One of the things we noticed, or someone else noticed, and then I checked and discovered, yes, it was true. Username password authentication is very easy, but it does cost in terms of performance. It's like an extra 200 to 300 milliseconds per request. While using tickets and tokens is much, much faster. So after you've logged in with username and password, you should go get a token. Like even if you're on premise, go get a token. So we've added a endpoint that you can like get my token. And this will work in online also. But basically that'll give you a nice token that you can use to authenticate, and your calls will go much, much faster. Then it'll go faster than WCF. That's a good thing. So yeah, OAuth and SuperID, we don't really do it, or at least this library doesn't do anything about that. There are a whole bunch of OAuth libraries and frameworks for Node already, and my initial my gut feeling is like you should probably use those to get the token, and then you can stick that into our client once you've gotten the token out of the JWT. I think that's the right approach. Yes, yeah, Tony says yes. But I'm not the one writing third-party clients, so looking for feedback here. This is very much sort of on the experimental side. I have no idea if any of this is kind of the right approach. It's like I cooked this up. Beaker, that's you lot. Will suffer the consequences. So, configuring requests. I should coming to the end. The Web API has some hidden features. If you send the accept language or SO language, then we will do language parsing for you. So we will do things like, if there are resource string IDs in square brackets, those will be converted into the appropriate language in the response. If there's a multi-language string in something, then we'll extract the correctest language string from that and pass that back. So if you said you like English, then you'll get the English language strings. And if you said, no, I would like Norwegian, you will get Norwegian if that's available. And this is something the HTTP API, the Web API does on their server side. Like it does this before sending the request back to you. So that's a nice thing. Sometimes you would like this to happen, sometimes you would not. So there's a way to configure, you can declare what language you would like, sort of explicitly when you set up, or you can do this with a nice options object, so that will set all the options in one go. And this will then percolate down to all the requests. You'll get all the answers you get will kind of be processed into one particular language. You can configure these things per agent, so you can actually, you don't have to use the agents API to kind of make new agents. You could make one by yourself and tell it like, do not parse strings for me, or basically turn this off, or please turn it on. Or you can do it per request, like you say, make me. Normally, when you call the agents API, I don't do language translations. That's the first line. But then when we're actually going to go get this contact entity, then in that case, no, I want you to do it for this particular language. Like for this request, use these language options. And it will kind of, okay. Then the next request, it doesn't have to. So you have quite a bit of flexibility of like how much configuration do you want to deal with. But it's convenient when you want to display data, you don't have to deal with kind of doing the language parsing sort of on the client side. It's handled for you on the server side. Canceling requests. You do a request and you put the little spinner up, and if somebody pushes a cancel button, you would like to stop the request from completing. And there is support for this in the library that we're using under the covers. So there's a way to access this. So basically, when on the agent there's a make options object function. That gives you an option that you can pass into the request. So you say get contact number 1, and then there's an options thing in there. And inside the options object, there is a cancel token that then gets made. Like that happens inside the options. It sets up one of these cancellation tokens for us. And basically, we can then at any point kind of go cancel token, cancel, and pass in a message. And that will interrupt whatever or stop the request, assuming it hasn't finished. And it will sort of fire off into the catch, the error handling part of the branches. So it'll fire off an exception, essentially, and we can then switch on the message or take away the spinner and at least react to the fact that, okay, this request has been stopped. So, but for the most part, it's like, you're not going to need this, hopefully. So it's on the options, like you need an options object with this cancellation token But for the most part, hopefully requests don't need to be canceled. They should just work. And there's another way you can monitor how the request is going. If you have an options object, you can stick a request status property on it, and that will be updated as the request proceeds. So it'll like start out as pending, and then once it's complete, it's marked as completed. Or if it's canceled or failed, it'll get a different status for that. So that you, of course, you could busy wait on it. Don't do that. But it's at least a way for you to quickly check, like, how is it going with this request? Is it busted or not? So there's very few states on this. It's not terribly complex. But that gives us a way to kind of easily access what's going on. Axios is the library we use underneath. It's a HTTP library that works both client-side and server-side. It's got a whole bunch of features. You can configure it in 60 different ways. I made it so you could stick your own sort of instance in instead of having it make its own. So do that dependency inversion of control thing, dependency injection. Unfortunately, that seems to be broken. So it's like, oh wait, I need more tests around that, obviously. But the idea is you could, at least you can do this with the configuration. You can say, oh, there's a request transformation function you can pass in. Like, so whenever a request comes in, just log the request, headers and so on. So when you do a request, it'll like, you can see on the log file all the requests that are happening in the background. All right, we are done. This is all very experimental still. So, the node package definitely not quite ready for production yet. But we ask questions, give me suggestions, comments, please. Anyone? Hmm?
Is that node package available now?
Yes.
In which version of the SuperOffice
Is what? Which version?
version of the SuperOffice is
Any version with the WebAPI. So that would be, I think, from 8.1 onwards. The API kind of grows quite gradually. It's the agents API is fairly stable. Like there are very few breaking changes in the services and so on. So we don't have versioning in quite the same way as kind of the SOAP services. So you can take kind of the most current version here. You'll see it's the library's got version 1 on it. Once we're more happy with it, I'll bump it up to version 8 point whatever we're using and try and stay in sync with our releases. So at the moment it's version 1, very experimental. But yeah, it works across versions. So and for the simple basic stuff like getting contact information and so on, that's version 8.1 onwards has the WebAPI stuff. No? Any other questions? Good. Woohoo!